Good morning. I was working on the Yamaha that I put that teaser video out on, and when I received a call, or more correctly, I received a PM from a gentleman who lives near me, who is a friend of a friend, and has this Rotel RB-1092, yeah, 500 watt per channel amplifier. Now, I took a quick look at the schematic and I was really hesitant to take this on. This is a Class D amplifier, and the schematic shows some support circuitry, but the amplifier modules themselves are what are known as ICE power. They are Class D, very efficient, ridiculously light, put out tons of power, but they're simply shown as a block on the diagram. A lot of manufacturers have started using these. This is now a mature technology. I believe they were patented in '99 or 2000. And you'll see these modules in nameplates like Macintosh, Marantz, Paradigm, I believe, uses them. So they're getting to be ubiquitous, but I don't think there's anything wrong with the ICE modules, because the gentleman who I spoke with, it seems pretty sharp, had explained to me when I asked him a few questions that he's not getting AC power to the module. So we're going to look at the section that actually turns this thing on, and I believe that's where we're going to find the problem. So we're going to pop the cover, and then we're going to look at the schematic. Okay, so I have the cover off, and as you can see, we have two modules, left and the right channel, and we have a protect and speaker terminal board, and we have our power on board. This is where I believe we're going to find our problem. One of the symptoms that the owner told me was it was not reliably turning on. He said if you unplugged it for a while, it would occasionally come on, but now I don't think it's coming on at all. And we're going to look at the schematic, and I'll explain how this works. This is a schematic of the entire amplifier. If you look, we have two ICE power modules here, associated protection circuitry here. We have some chokes on the output to take out the ultrasonic products left over after the amplifier amplifies the signal. And then we go to our outputs here. We have a trigger module that takes a trigger signal from the preamp to turn the amplifier on. And lastly, we have the module that actually turns it on. And I want to focus on that because I believe that's where we're going to find our problem. If you see, our power comes in from the outlet. And I'm in the US where the voltage is 120 volts at 60 hertz. So we have a line, a ground, and a neutral. Our line goes through a power switch here, and it goes into our first relay. This is the line relay. The neutral goes directly into the neutral relay. So we have a relay for each terminal coming from our power. We have a line relay, we have a neutral relay. A trigger signal from here will pull the relays in through the transistor, and if that's in the off position, the power switch on the front will also do the same thing. We need to see what's going on with our relays. Gentleman I talked to said he was not getting 120 volts out of this. We should have 120 in, we should have 120 out. Okay, so I am looking at the AC power that is coming into our power module. And when I turn it on, we have a good solid 123 volts coming from the AC outlet into the amplifier. The amplifiers don't appear to be on. So let's see what's coming out of the module. And we have nothing coming out of here. However, I believe that's where we're going to find our problem. We don't have any voltage. I had found if I tapped the relays before, I was getting something. Yeah, see that? I had the trigger switch in the wrong position. I'm going to set the auto ranging up. We may have burnt contacts or a bad solder joint on this board. It looks like, oh, the amplifier kicked in for a moment. I think we have burned contacts. We may have to replace these relays. But we're going to have to pull the board up, take a look at it, get the part numbers off the relays, and see what we get from there. Okay, I've got the one relay pulled out of here, and you can see the relay contacts were doubled up. If you look at the relay, I have 12 volts I'm going to put into here, and I'm going across the contacts here, which are the switch points. So here's the meter. I'm going to turn the power supply on. And we have no continuity. I'm going to take the relay, energize and de-energize. You should hear it click. This relay is not working at all. I found some on DigiKey and Mouser both. They're about $3 each. These relays are going to be replaced. Okay, so I'm back at this Rotel. Let's fast forward 3-4 days later. I ordered some relays from Mouser, and now we're going to find out if I ordered the right ones. The original relays are manufacturer discontinued, but I got some that should be close enough. And at this point, it might not be a bad idea for those of you who aren't familiar with relays to just discuss a little Relay 101. I went looking for images on the internet, and I tripped across a site I found pretty interesting. So I'm going to go on a little bit of a tangent here. There's a website for a company known as Embetronics. They do embedded controller and driver solutions for Internet of Things and other things like that. They have a lot of tutorials. They're based in India, and they had probably the best graphic and explanation of relays I'd seen yet. So I'm going to put this up on the screen so you can see it. One of the things when I was really new at this I had trouble figuring out is you had contacts that were labeled normally open and normally closed, and I could never figure out if that was the relay energized or de-energized. Well, normally closed is with the relay de-energized. Normally open is with the relay de-energized. When you energize it, it changes states. So I hope that clears that up. It was just one of those things I was never quite sure about. These pictures really explain well what the relay does. The relays are nothing more than electromagnetically controlled switches. So you can take a low current and switch a high current. You find them in all kinds of things, refrigerators, cars. Your car is a horn relay. Relay takes a lot of current. They don't want to have a high current switch in the steering wheel, so they use a relay. Anyway, let's see if the relays I got are going to fit and work in here. I believe they will, but let's take a quick look. Okay, so this is one of the relays I took out of there. And if you recall, we tested this and it didn't work at all. I'm going to put it on audible continuity so you can hear what I'm talking about. And if we pull the relay in, it works when you tap it, just like when I tapped it and the amplifier came on for a little bit. But this relay is not good. So let's take a look at the relays I got to replace it. They look pretty good. Form factor is the same, spacing is the same, but this has the pins for normally closed. This is not a problem because the pins are spaced well. If you look here, you see everything lines up, so we are just going to cut these guys off. And I'm going to test it like I tested the other one, and you should hear it squeal constantly whenever the relay is activated. So I'm confident this is going to fix our problem. Before I do that though, I want to point out something in the design of this. I was wondering why these contacts had burned so badly over time. You saw in the circuit board that they had doubled them up, and when I look here, I see they have capacitors here and here to mitigate arcing. In fact, this is C102, C103, and if you look at the parts list, you can see those are what they call spark killers. However, even with these in there, the arcing will eventually destroy these again. I don't know if it's a design flaw, planned obsolescence, or what, but this is just something that happens with stuff like this. I'll just replace them. I told the owner if he liked, I would order a spare set for the future. I don't know how old this thing is. It could be 15 years old. I think it was produced around 2007, 2008. Not sure. I'd have to look that up. But in any event, I'm going to change these out, and we're going to see how this thing does. Okay, so I've got one of the new relays put in here. So we're going to take the other one out and put the new one in. Now, all you have to do to get this to fit where this one was, right here, is cut off these two pins. We don't need them. We don't use them. Those are the normally closed. They're not going to be used in this application. So all we do, we reach down in there and cut them as flush as we can. And they cut really easily. Okay. There, that should be fine. Now we'll remove the old one. Okay, try and get these wires out of the way. We don't want to melt anything. And I'm going to put the camera back a little bit. I'm going to have my head in the view here. I wear my visor because I do better work when I can see what I'm doing. Here we go. Okay, old one out. New one just drops right in. Okay, put some solder up here. Okay. Try to solder a few pins and then make sure everything is seated all the way, and then the soldered pins will hold everything in. Having more hands would sure be helpful. I don't know if anyone read the book Project Hail Mary, but I wish I had as many hands as Rocky does. Okay, so we've got both our relays in. So I'm going to seat this, and we're going to power check it and see if this thing comes on. If you remember, there's a green LED in each module that'll light up when it turns on. Okay, I've got both relays installed. I have a couple of screws in the board to hold it down. We're going to turn it on, and we should see a couple of green LEDs come on in our ICE modules. Let's see, are we pulling any current here? Yeah, we're pulling about a ½ amp. And you can't see the LEDs because of the angle, so let me move this. And if you look down here and here, you should be able to see green LEDs on. So this thing's fired up. So we're going to put it on the distortion analyzer and see how much power we can push out of this till it trips the breaker on my bench. Okay, so I don't know how common this is on newer audio equipment. I deal mostly in vintage stuff, but this is the first time I've seen on a piece of home audio equipment Nutrix speak-on connectors. These are usually reserved for pro audio equipment, but maybe they started using it on home audio stuff. This thing's 500 watts a channel. It could easily do PA work. So anyhow, it just so happens that from my days as a weekend warrior / gigging musician, I have the right cables. These are Nutrix speak-ons. So they go in off on an angle like this, and then they twist and lock in like that. So we're going to use these to hook it up just because I have them. Now I have two of them, but I don't know what I did with the second one, so we're going to have to pause this for a moment. Okay, I got my other speak-on connector. I had left it over the other side of the garage where I have all this old stuff. So I'm going to turn this thing on, and then we're going to talk a little bit about Class D amplifiers and how they're different than the usual Class A or Class AB that we normally see. Those are ultrasonic products. This is what happens with Class D amplifiers. You don't hear this, it's far above the range of human hearing. We can determine what that frequency is Okay. I don't know why channel 2 is not triggering the same, but anyway, if we put the cursors on, we are looking at about 400 kilohertz, 389. These products don't affect the audio. So I'm going to put this back to where it normally sits, and we feed enough signal in, and it looks fine. That's 50 watts a channel. This thing should put out 10 times that much. So let's see what we can get. And I got to keep an eye on the bench here because I've only got 15 amp breakers feeding this bench. These things are very efficient, but that means they pull more power out of the wall. So let's see. Digit selector. 77. Okay, 7 amps, 221 watts. Okay. You hear my dummy load screaming. We're up to 300, about 375 watts a channel, pulling 11 amps. $435. Yeah, starting to get around clipping. There you go, over 500 watts a channel. This thing will put stretch marks on your woofers for sure. So anyhow, that was the only problem we had with this amplifier. I guess it's an Achilles heel, but these power cycling will eventually kill these relays. Fortunately, they were inexpensive. The ones I looked at were $3, but they were the incorrect ones. These were about $5 a piece. So anyhow, that concludes this video. I hope you enjoyed it. Hope you learned something. I always do every time I make one of these. And as always, I like giving back to the community that's given me so much. Thanks a lot, folks.